presentation for today, which is about using OVN to build a NAT gateway, advantages and challenges by Yi Yang. Roll it.
Hi, my name is Yi Yang. I have talked many times in OVS and OVN conference since 2017. Today, my topic is using OVN to build NAT gateway, advantages and challenges. First, I will talk about why we use OVN, what advantages OVN has. Second, I will tell you how we use the OVN to build a NAT gateway. Then I will show you our demo setup and demonstrate our OVN-based NAT gateway prototype. And last, I'll point out OVN challenges we are facing and give some advice to OVN community in order to improve or optimize these issues. Why shall we use the OVN to build NAT gateway? Because it is simpler. It can use OVSDB to configure everything. We needn't take care of openflow pipeline. That means we can build a NAT gateway without openflow and vSwitch knowledge. This is really attractive. OVN can configure SNAT, DNAT, and QoS. SNAT is used to access the internet. DNAT is used to provide web service for public internet users. QoS is used to limit bandwidth. OVN also can configure virtual network for compute node and create BRINT bridge and VXLAN port on demand. This is really good layer 3 abstraction. Here, I teach you to build a NAT gateway step by step. Of course, you need to have a machine for this. It can access the internet. At first, you need to install OVN packages, OVN Central, and OVN Host. Then enable OVSDB server listening ports in order that compute chances can connect to southbound OVSDB server. You also need to configure some basic parameters for OVN. For example, OVN bridge name for physical network. Then create a logical router, logical switches, logical switch ports. Configure SNAT, DNAT, QoS. In another machine, it acts as a compute node. We run virtual machine on it. Then connect to this NAT gateway to access the internet or provide internet service for public users. You need to run many commands to finish them on 2 machines. I have uploaded 2 scripts to my Git repo. You need to change IPs per your environment. You just run ovn-gateway.sh in your machine to set up NAT gateway. It does all the aforementioned steps. Then run ovn-compute.sh in another machine to set up OVN compute chances. After them, everything is ready for use. This is my demo setup. There are 3 machines: OVN host, NAT gateway, and client server machine. OVN host is a compute node host name is Yang host 1. We run virtual machine in this machine. This virtual machine attaches its virtual network port to behind bridge. OVN created a VXLAN port in behind bridge so it can communicate with NAT gateway by virtual network 192.168.1.0 by VXLAN tunnel. VXLAN local IP and the remote IP in subnet 11.11.8.0 net mask is 24. As its name shows, NAT gateway is just NAT gateway. Host name is Yang-GW1. Here I illustrate logical switch, logical router, bridges, and connections between them. Default gateway IP or virtual network is configured in logical router. It's 192.168.1.1. VM in OVN host is configured with this default gateway IP by DHCP. Logical switch controls QS. Finally, openflow meter action does QS. Logical router controls SNAT. Openflow CT action implements SNAT. DNAT is done by load balance. SNAT IP 100.73.95.248 and DNAT IP 100.73.95.246 are physical networks IPs. They are in the same subnet with the third machine, client or server machine. This client or server machine is used to verify SNAT, DNAT, and QS. Its host name is Yang-server 1. Here is time for demonstration. This is a NAT gateway. You can see logical switch 1, logical router 1, and the logical switch outside. Logical router 1 has SNAT IP and virtual network IP segment and net mask. Here, DNAT information is in load balance table. VIP is external IP and external port for internet access. IPC column is internal VM IP and port. QS information is in QS table. Here we limit bandwidth to 50 megabits per second. The default unit is kbps, kilobits per second. We have BRFA and BRINT bridges. BRFA is used to connect to public internet. OVN create BRINT and connect it to uh, BRFA by patch port. OVN port is a VXLAN port. It is used to connect computer chassis host 1. Local IP and remote IP are VXLAN tunnel source and destination IP. You can see two chances, LE-GW1 itself and LE-host1. VXLAN IPs are just local and remote IPs of VXLAN port. OS added 2 meters to do QoS, one for egress and the other for egress. This is LE-host1. We use the names, stable network names to demonstrate VM for convenience. VM1 is a virtual network port for VM. Its IP is 192.168.1.10. Default gateway is 192.168.1.1. Here we ping default gateway. It's okay. Actually, these ICMP request packets have been encapsulated by VXLAN port and went to NAT gateway LE-GW1. And ICMP reply packets from port 1 LE-GW1. Here we ping LE-server1. Its IP is 100.73.95.145. It's okay too. This is actually isolated. Let's check source IP in server-LE-server1 by TCP dump. You can see source IPs of these SMP request packets are indeed 100.73.95.248. It is just as an IP configured in logical router 1. We started HTTP server to check DNAT. This is a Python tree-based web server. It's slow in network namespace. Okay, it's ready. Here we use wget to access this DNAT IP. We don't specify port. It means default port 80. In virtual machine, this port is DNAT to 8080. Here you can see HTTP server and one HTTP GET. Client IP is 100.73.95.245. It's LE-server1's IP. Next, let's check QoS. First, we start iProf3 server in LE-server1, then start iProf3 client in VM. We have limited bandwidth to 50 megabits per second. Now you can see every second bandwidth is about 50 megabits per second. After 60 seconds, we can check every bandwidth. Here you can see it's really 50 megabits per second. We check QS in another direction. Here we start IPv3 server in VM but used 8080 port. This means we want to use DNAT to check QS. In LE server 1, we start IPv3 client but use DNAT IP and DNAT port. For IPv3 server, here every second bandwidth is still about 50 megabits per second. Average bandwidth is also 50 megabits per second. Yeah, but OVN also has some issues when it is used in large-scale production system. It creates a VXLAN port for every chassis. It is impossible if we want to connect 100,000 chassis to one NAT gateway because the maximum port number always allows is 32,768. In addition, ovn-gateway and OVSDB server will be overloaded and keep 100% CPU utilization always and cannot respond to any interoperation. Memory usage will increase dramatically. Finally, they will be OMQ'd if we create more than 10,000 logical routers and 10,000 logical switches. This is really unacceptable. About traffic statistics, it is also a big problem. We can get traffic statistics from meter stats, but it is really very difficult to map 2 meters to one specific QS item. While OVN cannot maintain this in QS table, especially if a NAT gateway machine is restarted, or OpenVSwitch is restarted. Meter ID will change. Meter to QS mappings will change. So it will make life easy if OVN can maintain these mappings in QoS table. Another important issue is contract state synchronization between master NAT node, master NAT gateway and slave NAT gateway. We expect CTZO ID is same in master gateway and in slave gateway, but it is impossible in the reality because every chassis manages its CTZO ID independently. Meter ID has the same issue. Our requirement is we can precisely duplicate master to slave. Same ZO ID, same meter ID for the same SNAT, same DNAT, and same QoS. So how can we fix these challenges? We give some advice to OVN community. We think OVN can create only one VXLAN port for all the chances to fix the scalability issue and the port number limitation. Then use the openflow to program this VXLAN port for different chances. OVN has meter management commands, but unfortunately, they are not for QoS. It will be great if OVN can manage meters for QoS and traffic statistics support for QoS. For contract state synchronization, we think OVN can use consistent ZO ID and meter ID allocation policy. If OVN settings are same, ZO ID and meter ID should be same. This is very helpful to master and slave node because the same ID means same thing, but not different thing. Okay, that's all. I'm done. Thank you.
All right. My mouse went to sleep and didn't want to wake up again. So thank you, everybody. I think we do not have Yi online. Let me just double check. No, we still don't have him online. So there is no opportunity to ask questions, but I guess he is available on the upstream mailing list. So if you do have questions, I think we could do it there. All right, so Ilya says that using an openflow, and it drops out of my thing. So using openflow program tunnels sounds like an interesting idea to explore. So yeah, we have some follow-up maybe that we can discuss over the mailing list. Let's see how that goes.